Section 3.1 discusses radian measure. Up until this point, we've looked at angles in terms of degrees. This chapter begins to shift our focus from degrees to radian measures. So the first thing we're going to talk about is what exactly is a radian. And we're going to use this picture to help us think about this. There is a definition here. Given any circle, and this does work with any circle, an angle that has its vertex at the center and it intercepts an arc. Now this was the arc that it intercepts. Remember, arc length is usually denoted by S, but it intercepts an arc that is equal in length to the radius. So here's the radius, and it turns out that the arc length is the same length of that. Then that angle is said to measure 1 radian. Okay, so it's kind of a confusing definition, but ideally what you got to figure out is that the arc length and the length of the radius are the same. And so that angle that it rotates through to get that arc length, that angle is considered 1 radian. Now we can mark off more than 1 radian. Let's suppose that, for example, we also took this and made this long. And let's suppose that the arc length in red was 2 times the radius. Okay, then if it is 2 times the radius, then the radian theta is going to be 2 radians, because you have 2 times the radius as the arc length and the radius is r, and that gives me theta, which would just reduce to 2. So here's a note for you. Later this will come up, but theta is given to the arc length divided by the radius. You don't have to know that now, but that's where that comes from. So then I could also have 3 radian. Suppose that my arc length was 3 times the radius's length, and my radius, of course, is just r. Then this being theta, theta would just be 3 radian. So the measure of angle theta, this angle here, would be 3 radian. And so hopefully you can see that. Now on the next page we're going to connect this to a bigger concept. What we know from geometry is that the circumference of the circle, that is the total distance around, is 2 pi times the radius. So if my total arc length here is 2 pi times the radius, and of course my radius is r, then the total amount of that circle in radians is just 2 pi radians. So here's what you need to know. Here's a connection you need to make. 360 degrees, or that whole angle, matches up to 2 pi radians. And we can use this as a conversion factor. Now, of course, we can simplify this. If we divided both sides by 2, we would get this, that 180 degrees is equal to pi radians. Now guys, we're talking about pi radians, but you know that pi is approximately 3.14159 blah 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 blah. Okay, I'm going to go back to our first page for just a second, and I want you to look at this. If this is 1, 2, 3, and a little more, there's your 180 degrees. Notice that there is approximately 3.14159 blah 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 radians in this first half a circle, and that's what we denote as pi. So you can see it visually and you can see it algebraically here. Now, the main thing, now that you have the idea of what a radian is, just a general concept, what we really want to do is just convert things from degrees to radians using this conversion factor. We have done this before in chapter 1, going from minutes to seconds and degrees to minutes, seconds, and feet to inches, and so on and so forth. But we're going to go attack that conversion one more time, and this time we're just going from degrees to radians and back and forth. So on the first page, I have you converting, first of all, degree measure to radian measure. So I know that I have 45 degrees, and my conversion factor is that there are 180 degrees in pi radians. So I need to think about this. I need to make sure I cancel these degrees. So on bottom I will also have to put degrees. I'm going to put the 180 degrees on bottom. That way those degree units will cancel out. And I'm going to put the pi radians on top. Now, I realize that 9 can go into both of these numbers. I know 9 goes into here 5 times, and then 9 goes into here 20 times. And now I realize, well, 5 can go into there 4 times, and 5, I'm sorry, blah, 5 can go into there 1 time, and 5 can go into here 4 times. So if I simplify this, this would be pi over 4 radians. Okay, so 45 degrees is equal to pi over 4 radians. And typically we do not write the word radians. Typically we would just say that 45 degrees is equal to pi over 4, and we would understand that we are in radian measure. Now, having a negative value does nothing to the process. We have a negative 270 degrees. Again, if you're trying to get rid of the degrees, put the 180 on bottom so those degree units cancel out, and put your pi radians on top. I'm going to reduce before I get going. Let's see, I can get rid of those zeros automatically. Divide by 10. And now let's see, 9 goes into both of these. It goes into here 3 times, and it goes into here twice. So this would turn out to be negative 3 pi over 2 radians. 270 degrees and negative 3 pi over 2 are equivalent in value. Just one is in degrees and one is in radians. And then the last one, 249.8 degrees. Well, I know they're 180 degrees in pi radians. Now notice something. I've already got decimals in this number. So what I'm going to do is just go ahead and enter this into my calculator. Do not put 3.14 in your calculator for pi. Use your calculator button for pi. Okay? And what you would type in is 249.8 times the pi button divided by 180, and you're going to get an approximate answer. It's going to be a decimal answer. You should get 4.360 radians. Okay, now I could have gotten approximates with the first two answers as well. These two answers are exact. This one is exact and this one is exact because I didn't put in 3.14 for pi. But the third answer, of course, I did go ahead and type that in the calculator, so it is not exact. This one is an approximate answer. So be sure you note that. Okay, let's go the other way. If I have 9 pi over 4 radians, and I want to, now realize your radians is kind of on top there, and I want to go to degrees, then I'm going to put pi radians on bottom, so my radian measures will cancel, and I'm going to put my 180 degrees on top. Now notice what happens. The pi's also cancel, and I can clean this up very easily. 2 goes into here twice. Oh wait, 4 goes into all that. So let's say 4 goes into here once, and 4 goes into here 45 times. So when I multiply 9 times 45, let's see, 45 times 9 is 405 degrees, because I'm left with my little degree mark right there. So I just flipped my measure upside down to get rid of my radians. With negatives, it works the same. Negative 5 pi over 6 radians. Well, there are pi radians in 180 degrees. The pi's cancel. I know that 6 goes into here once and into here 30 times. And so when I multiply that, I get a negative 150 degrees. Remember, these are radians, so the radians also cancel. So then that is just simply 150 degrees. Now, 4.25, there's no pi here, but we understand this to be radians, and we'll talk about that in just a second. If I have 4.25 radians, then I divide by pi radians and multiply 180 degrees. Again, I'm going to get a decimal. So 4.25 times the 180 is 243.5 degrees. That's an approximate. Okay, because I put that pi in there as the pi button. Alright, So hopefully with this you can tell very easily how to switch from radians, degrees, and back and forth. Not a very hard process. Okay, on the next page I just want to bring something to your attention. From this point forward, if there is no unit of angle measure, then you understand that to be measured in radians. So unless it has the degree mark, you understand it to be radians. Now notice the difference. This is 30 degrees. This, around and around and around and around, back to here, is 30 radians. Big difference. So you've got to make sure from henceforward, if you mean degrees, it has a degree symbol. And if it doesn't have a degree symbol, you need to interpret that as radians. Otherwise, you're going to end up way out of where you should be. Alright, there are a lot of actual degree measures that we use in trig over and over again. We have our 30, 60, 90 triangle. We have our 45, 45, 90 triangle. We have our quadrantal angles that we look at. And you need to pretty much be able to tell what those are in radians without having to convert each and every time. So I gave you two things here to kind of compare for you and let you see the differences. This lists degrees and then radians, and in the radians we have the exact and the approximate. The approximate is when you take and you put in that 3.14159 for pi and calculate that with your calculator. So 30 degrees is represented exactly by pi over 6, and that would be 0.52 if you put pi over 6 in your calculator, which makes sense. Pi is 3 point something, and 3 over 6 is a half, so it'd be a little bit bigger than a half. And so that all of these are basically similar. 45 degrees is pi over 4. We converted that ourselves a minute ago. 60 degrees is pi over 3. And another way to think about this, guys, if I had pi over 3 and I wanted to change this to 60 degrees, I could do a simple substitution. Pi and 180 degrees are equivalent. So then that just gives me 60 degrees. When I just substitute 180 for pi, that's a way of converting also. It's just a little quicker. So you'll want to just kind of make note of these. 90 degrees is pi over 2. Of course, 180 equal to pi is our conversion factor itself, stemming from that last one. So most of those are familiar. In the days ahead, we're going to be looking at a unit circle. This is the first part of your unit circle that you may want to take note of. What we've done is we've compared the different degree marks that we normally have and put them in terms of radians. And so you can look at that. I'm not going to spend a lot of time on that, but that is there for your working. All right, lastly, know that we can always talk about trig values associated with angles in radian measure. But we don't think in radians, so in our mind we really have to convert back. What I know is this: pi is the same thing as 180 degrees. So 2 times 180, well, I would say 3 into 180 is 60, and that would give me a measure of 120 degrees. What I know is I'm thinking that this 2 pi over 3 is the same as 120 degrees. So what I want to do is I want to find tangent of 120 degrees. And when we look at our triangle, 120 degrees is in this quadrant. If this is 120 degrees, then this angle right here is 60. This is a 30, 60, 90, which is 1, 2, square root of 3. That one is negative. And tangent of that is going to be opposite over hypotenuse. And so our tangent would be this. So finding the tangent of an actual radian measure angle, no different than degrees, and in fact I switched mine to degrees so I can work on it because that's the way I think, and then you could go from there. Cosine of 4 pi over 3, negative 4 pi over 3, again I'm going to stick that 180 degrees in there for pi. 3 goes into that, 60 degrees, so that becomes a negative 240 degrees. Now I've got to get this back between 0 and 360. I'm finding a coterminal angle, which is 120. If that looks right to y'all. And so, hey, we're back to this triangle up here. No need to draw a new one. Cosine of that is going to be adjacent, which would be negative 1, over the hypotenuse, which is 2. So that would just be a negative 1/2. Let me double check myself. Yay, very good. Now, the last slide I'm going to do, just very quickly, is just something that's just kind of minimal. If I can get to that last slide. Let's see, let me move this down a little bit. Okay, my little recording thing I'm going to pause. Okay. This will be very minimal. It's just a think page real quickly. Through how many radians will the hour hand on the clock rotate in 24 hours? Well, if you think about the hour hand on the clock, I don't know why I drew a XY chart. Let's draw us a clock. 12, 6, 3, and 9. The hour hand in 24 hours is going to go around twice. That's 2 rotations. Well, 2 rotations, and it's 2 pi around each one, would be 4 pi radians that it would go in 24 hours. Now the 4 hours is a little different. In 4 hours, our hour hand, let's just say it went 1, 2, 3, 4. Well, what we have to realize is that would be a third of a rotation. So if one rotation is 2 pi, a third of that would be 2 pi over 3 radians, because 4 hours is 1/3 of a rotation, and we know that one rotation is 360 degrees, or 2 pi radians. Now a circular pulley is rotating about its center. It wants to know how many radians would it turn in 8 rotations. Well, remember, if it's 8 rotations, we know that one rotation is 2 pi radians. So it would be 16 pi radians if you wanted to set it up like a problem. Through 30 rotations, well, if you had 30 rotations, we know that one rotation of a circle is 2 pi radians, and so that would give it 60 pi radians worth of rotations. Now this stuff again is a think page. It's not our main focus, but I just wanted to throw that out at you, just help you to look at it one more time. Alright guys, remember as always, if you have questions, we will be able to answer some of those in class, but the main thing here is, can you convert to radians from degrees and back and forth, and then can you find trig values based on those radians without any trouble?